Okay, so let's have another problem, but this time we would be making use of triangle as our basic shape. So in this problem, we would be computing for the product of inertia of the triangular area shown in the figure with respect to the given x and y axis. So this is to be your x-axis, and this is to be your y-axis. So we would be computing for the product of inertia in reference to both of these reference axes right here. Similarly, like in the previous example, which is this one right here, we would be making use of this table for us to have a more organized solution. So the difference between this method right here as of this method right here is that our IXY and PXY wouldn't be 0 any longer. Since as you can see here, this shape right here is not symmetrical in nature. Thus, we would be making use of this formula right here for PXY or IXY. So as you can see here, this is to be the formula for the product of inertia about the centroid of a right triangle. And as you can see here, do you think that this is to be a right triangle? So as per inspection, this is not a right triangle. So what I would be doing now is that I would be dividing this into right triangles. So I would be passing through a line here. And there, we actually have two right triangles right here already. So let's label this one as, well, triangle number 1. Triangle number 1 and triangle number 2. So I would just be writing it here for it to be more neat. So 1 and 2. So this is to be triangle 1 and triangle 2. Okay, so for the product of inertia of this first triangle, so we would be making use of this equation right here. So that is to be, by the way, this is to be 3 inches, as said here. So for PXY of number 1, this is to be equal to, by the way, as you can see in this part right here, this should be negative if your triangle is to be in this orientation right here. So if it is facing there. And as you can see in this triangle right here, this triangle is facing to the left. So instead of it being negative, so we would now be removing the negative symbol. So there it should be positive. And BH squared over 72 is as follows. So our base is to be 3. So 3 squared. And our H is to be 9. So 9 times 9 squared divided by 72. And from that, our product of inertia about its centroidal axis is to be equal to, so looking at the calculator to your left, that is to be 3 squared. So 3 times 3 times 9 squared. So times 9 times 9. So, and we would be dividing this by 72. And our answer here would be equal to 10.125. So this is to be positive 10.125. This is to be in inches raised to 4th. So inch raised to 4th. Okay, and as for the second one, so what would be the centroidal product of inertia of this section right here? So if this is to be 3 inches, this dimension right here is to be 9 inches minus 3 inches. So this is to be 6 inches. So it would be this one right here. So our base would now be equal to 6 squared and our height is still 9 squared. So divided by 72. But take note, guys, that the orientation for this triangle right here is facing right. So it means that this value right here should be negative. So negative siya. So our answer here would be negative. So looking once again to the calculator to your left. So 6 squared times 9 squared divided by 72, that is to be 40.5. So times negative 1, I should say. So we forgot the negative symbol. So negative 40.5. Okay, so now what's next? Let's solve for the respective areas. So for the area for the first triangle, so it would be quite simple. We would just be making use of the basic formula of 1/2 base times height. And for area number 1, so I wouldn't be writing it any longer. Just look at the calculator to your left. So the area for the first triangle is to be 1/2. So divided by 2. So 1/2 of 3 times 9. And our area then is equal to 13.5 square inches. So 13.5 And as for number 2 or triangle number 2, so our height would be 9 inches and our base is to be 6 inches. So that is to be 1/2 9 times 6. So this is to be equal to 27 square inches. So 27. And how about for our board X? So for our board X, it would be this distance right here from this axis right here up until the centroid of the triangle that you're analyzing. And this distance right here is equal to 2/3 of the base. So this is 2/3. So as you can see here, this is to be 2/3 of the base. And 2/3 of 3. So 3 times 2 over 3. So that would be equal to 2. But let's just back it up with a solution. So 3 times 2/3. So that is to be 2. So this is to be 2 inches. But for our board Y, it would be this distance right here. And this distance right here is to be equal to 1/3 times height. So 1/3 times height. So if you're not following, I think it is better for you to watch our pre-recorded lecture about centroids first if you're not sure where this came from, this 1/3 height. And 1/3 times 9, which is the height, is equal to 3. So our board Y is equal to 3 inches. And as for our second figure, so for our board X, it would be from this axis right here up until this centroid right here. And this dimension right here is to be equal to 1/3 of this whole dimension right here, so times 6. But this one right here is to be equal to, as you can see, 3 inches. So for our board X, that is to be equal to 3 inches plus 1/3 times 6, which is, well, this distance right here. So looking once again to the calculator to your left, that is to be 3 plus 6 over 3, so that is to be 5 inches. So 5. And as for our board Y, that would be this height right here. So it would be this one right here. And that is to be equal to 1/3 of the height. So 1/3 times 9. So that is also 3 inches. So the next thing that we should do now is that we would be multiplying these values right here. So 13.5 times 2 times 3, that is to be equal to 81. So 81. And as for this one right here, so for the second row, that is to be 27 times 5 times 3, that is equal to 405. So 405. So this is to be in square inches, square inches. So inch, 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 square inches. So by the way, this isn't square inches. So this is to be inches raised to 4th and inches raised to 4th. And what we would be doing next is that we would be getting its summation of, the summation of the products of inertia and the transfer formula. So summation. So adding both of this, so that is to be equal to, so 10.125 minus 40.5, that is equal to negative 30.375. So negative 30.375. And as for the summation here, so summation of our transfer formula would be 81 plus 405, and that is to be 486. So 486 inches raised to 4. And this one right here is erroneous since this is not mm raised to 4th. So I'm sorry about that. This should be inches raised to 4th. Okay, so now since our formula is equal to IXY or PXY, so whichever the case may be, so plus our transfer formula, so it would be this ones respectively. So with that, this is to be equal to negative 30.375 inches raised to 4 plus 486 inches raised to 4. So getting the answer here, negative 30.375 plus 486, that is to be equal to 455.625. So 455.625 inches raised to 4. So this is to be our answer for this particular problem right here. So that's it for this pre-recorded lecture. If there are any questions, feel free to comment and feel free to message me.